Okay, we're going to work on our 45 motors again. So we got some new flywheels here. It says 45 Sportster 4 and 5/8. So we're thinking these are 45 and not Sportster. Appears we got an extra bolt for free. I got dirty already. Here, I need a rag. Oh, it's tight too. Hey, it's American. Ooh, jeez. Yeah, he actually tightened that. Now you know how you tell the 45 and not Sportster? They have flywheel thrust washers here, see? Sportsters don't have that. Okay. It looks like they're 45s. They have dinky holes too. So it appears we got one little crappy ass timing mark is all we're going to get. So we're going to have to figure out what the timing mark is. And we have one of those too. So I wonder what kind of a timing we get on this thing. I like how they stuttered 3 S's in there. I don't know what that's supposed to mean. Maybe that's 9. Is that 9 or is that S's? Or 6? Fancy. And evidently they put lock holes in that we don't use. Alright, what's the other motor look like over here? Okay, there's where we left off on this side. Seems like we're inventing new bearings. Okay, that is a mock-up race. There's those pieces I still need to make. There, it looks like a real race there. That looks like an expensive one I cut down. Appears to be a new shaft. That's next week's project. Okay, so this set already cleaned. That disappeared already. Oh, he's got a different number on this one. So that must be some kind of identification number for him. Serial number, I guess. I'm guessing that is that's a screw up. See, they stuttered. They didn't stutter on this one. They stuttered on this one. Okay, so the timing marks are better on this one. See how this one you can actually see it? Unlike this one over here, it's hard to see. See, nice deep one, a nice crappy one. We still don't know what the timing mark is. Now you're not supposed to mix these up, I guess. They might be different. There's our stock 45 small wheel there. So the difference in stroke. See the difference? Just a little bit. Almost an inch. That's the one to rebalance. And volume fixed. Okay, so I gotta go clean this stuff all up again. I might as well clean these too. They've been sitting for a while. Okay, I'll be back. Some cleaning. Just go like that. Now we're on record. See how it says record?
Okay.
Alright. We'll repeat. Do our timing mark. You got this degree wheel here. You can buy those all over the place. Here's a custom made one probably. So this one's smaller than the flywheel. This one's bigger than the flywheel, so it's hard to read. You can't go like that. That's not accurate. It has to be concentric, which means it runs on the same center line. So if you center it on the OD where it's all the way around, then you got accurate numbers. Okay, we got to figure out what center line dimension here is first. So we need something that's going to tell us that. So we got to figure out where the center of the hole is at. So this is in the middle. You have to guess the middle of that one. So I guess it's pretty close to that kind of number. Looks pretty damn close to me. Okay, so that is our center line. Now can I do that 2 times in a row? That would be asking a lot. Looks pretty damn close. Okay, I'm satisfied with that. Now you can see the errors. See, this one's closer together than this one by a little bit. So even though it looks the same, they're not the same. That's 435 thousandths. That one's 450 thousandths. There's 15 thou difference. Can you tolerate 15 thou error? You don't care either? Okay.
I don't know.
That's good to me. Okay, so now this is the center. The flywheel is not top dead center. Top dead center is going to be on the front cylinder, be here, rear cylinder be here. There's a 45-degree V angle and a 45 motor on the cylinders here. I have to look up. There's a 45-degree V angle on these, so half of that would be 22.5 degrees. So this line is 22.5 degrees from the other 2 lines. So this mark and this mark should be 22.5 if that's a TDC mark. If that's a timing mark, it would be different. Did that confuse you? So there's my top dead center. Where his mark is, mark's way down there. So I'm going to go ahead and mark this where I can kind of see it. Okay, so we put that right on 0. Make this thing as concentric as I can, so it's even all the way around. Rotate until it's round. Okay, so see how that's right on 22.5 degrees. So that means that's a top dead center mark for rear cylinder. There's a front cylinder. No, that would be the front cylinder. Because the crank pin would be here. Yeah, so it looks like the timing mark is, should be, so we make that the actual timing mark, TDC mark. Center it. So, okay, I'm on my 22.5 here. We're on 0 here. And see how they're on 30 degrees even right here. So we're on 30 degrees. So that's fairly retarded in my opinion, but that's probably what stock Harley timing mark is. On my race bike, it likes 40 degrees of lead in my flathead. That's where I run mine at. So, to get that number on your bike, you got your windy timing mark you got in your hole. Instead of being right there, you'd have to put the mark to the back of the hole to get that one on center, see? To come up with 40 degrees. That's why you cheat and move them way to the back. But it'd be more than that because the whole window's that far. Okay, so it looks like he's using 30 degrees as a timing mark. So probably what I will do is we're going to make a 40 degree one because I like 40 degrees. Okay, let's see, now we can check it this way here. 0's over there. Concentric. 22.5 degrees is right there. That mark appears to be off over here though, see? Concentric. Yep, I moved it. So see how it's off just a little bit? So there's an error in here someplace. So is it me or is it them? So we'll come back and double check. Looks like it's me. It looked like it was on center before, but it's not. It's over there. Double check center. These scales have a tweak to them, see? Could have been so no more curve in it. The curve affects your number. Okay, it looks like it's centered now. Let's see if that made it better. That helped quite a bit. Now it looks like it's on center, see? We're at 30, and we want to be at 40. Okay, so there's our 40-degree mark. Four marks means what? 40 degrees. Jeez, I thought you'd get that one. I made that too complicated?
I'm tired.
You're tired. I got more sleep than I did. Alright, there's 40 degrees. Let's help you to figure out what that means. Okay. Gets rid of the sharp edge. It also kind of highlights the holes a little bit too. Okay, these have been marked. So now you know officially what you have, right? Okay, that was the easy part. Now I got more work to do now. Okay, which set do you want? Yet to be determined? Okay, we'll figure that out down the road. Okay, now we gotta balance this thing. So where's all the parts we're gonna use? Gear shaft, engine shaft, cranking pin. One crank pin. You didn't know your box of stuff was right there?
Mm-mm.
Oh, your box shit right there. Okay, so 2 crank pins away. Your pistons. 255. Another set. We're gonna measure pistons. What else are we gonna measure?
Rods?
Rods. You got any rods? Rods are all marked up. You have to find some rods. All right. See what parts I can dig up. More likely I'm probably missing some parts. Yeah, I got that. You got one of these too. Perfect. There's another one. I like that one. Ooh, it still works. Okay, so this set is standard. They're actually about 7th over. This set here is a 65 over plus a little bit. We get rings. Ooh, we got rings. Those are fancy rings too. Those aren't Hastings rings. Those are fancy rings. Chrome plated, I like that. That's good. Nice rings. Let's see, how much is this piston weighs? 220 grams, it says. Do you believe that? Which one are we using? The small one or the big one? You got 804 and 809. Here's somebody wrote 5 thousandths on it. The scale's already off. I'll take that. What's it supposed to weigh? 220. No, it's 219.6. Off by 4/10 of a gram. Get a titty on it. Cut the titty off, you like that? That one's 2/10 heavier though. See this? See how the file was hitting on the outside edges here when I hit it? You flip it over. See the difference? So this one actually cuts the center. This one here was cutting the outside edges. So I haven't marked this file for top and bottom yet. Red means top. So now, when I knock that titty off, see its red goes up. See how it doesn't dig in on the sides now? Because all files have a curve to them. Can't necessarily see it, but it's there. Okay, the scale's at 3 under now. This is an accurate scale. Someone said it was a power differences makes that happen. Which number you want, 0 or -1? Or +1? Got a number you like? Go with that one?
Mm-hmm. Can't make up its mind.
No. It was 3 and now it's 1, so it's closer. How about this one? This one was under. That's even lighter now. That was a 2/10 change though. On 2 on that, 1 on that. It's still 0. Oh, there's our negative. Nope, we're 0 again. Let's back up to 6. I mean, it's probably going to be 1 now because I moved it. Yeah. Nothing like being accurate, huh? Alright, so we got 6. And we got +1 on this one. Ooh, +2 now. It's gone up. Okay, so this one's heavy. This is +2. I better not write that on that. I'll think that's a size. It don't matter. The average is just under 220 though. Okay, what's this one weigh? Ooh, this one's a lot lighter. It's 212.
It was smaller.
You sure? 755. Those are both the same. 60. This is the big one. The underlined it in red. Ooh. You mean they didn't cut them to make them equal weight? Look the same. It's heavy. Do a titty on this one too. $12.4. 0. 212.4. That one was 5, wasn't it? Nope, that's the same. 212.4 on both. These are more accurate. Too bad they're not yours. So that means I got to use 2 different balance sheets because there are 8 grams difference. Think the rings weight are different too? Probably. 60 thou difference. $68.7. What the hell's going on? That's gonna be 89 grams. Something's not right. Different rings.
Mm-hmm.
They're different.
Yeah, the oil rings are different.
Totally different style.
Yeah.
Oil rings. So these are what, 56 bore. These are the same bore. Can't be the same bore. You got 2 different bore sizes we're dealing with. Wonderful. 1, 2, 1, 2, 5. So each ring's different width, see. 1.2 mil top, 1.5 mil second, and 2.8 mil oil. These are 1.5, both rings. 4 millimeter. So they have a different ring package for each set of pistons. They're not even the same rings. So you can't.
So
They're totally different each piston.
so they're cut for these rings.
Way too close. You don't need to be anywhere that close. Yeah, they're individually cut for each motor. So he didn't standardize the rings when they made the pistons for me. They got rings and made the pistons fit. So this set here takes the fat rings. So not only do you have the heaviest piston, you also have the heaviest rings. By quite a bit. So this one has a narrow top ring. So you can see how it's narrower than the second one. 55, 66, 115. It's a totally different ring stack. See how they're all different. You can see how close the wrist pin is here. See how fat it is over here. That's because it's a different ring stack altogether. Top ring's in the same spot. At least it should be. 198 roughly. 200, yeah, so they're in the same spot. So they start out the same, and then the ring stack compensates for a different length as you go down. So this one here has a lot more meat because the rings are thinner. So each box is different. So that means each flywheel has to be balanced 2 per them, or I can't just do a common balance for all of these, because each one's different. Kind of sucks. Oh well. So now we know. Good thing we checked, huh? Okay, now you got nice chrome top rings. What did he get? He's got metal top rings. See, these are steel top rings. So these are higher performance. Okay. Oh, you got metal. These are metal ones too. See how they're coated on the side? As you means they're metal. They're steel rings, not cast iron. Cast iron rings are real dull looking. Not just a coating, it's material too. Can I mix the rings up? Does it matter? And the oil ring. These are going to be light tension ring here. These are going to be a heavier tension probably. The lighter the oil ring, the more horsepower you get, but the less oil control you get. Everything's a trade-off. Alright, so we gotta figure out all of this. So this box is yours. This box is his. You have to pick a set of flywheels though. Which one you want? Make a decision.
Okay, I'll take this set.
How do you know that's a set?
Because they have the same number.
Oh, damn, you're catching on to all this stuff. Okay, so you don't want this guy, you don't want the bad double stamped ones?
Mm-mm.
So you want the ones I had mocked up before, huh? Okay, 679, 679. Okay. Whose are these? Whose are these? Can you read that?
ARKO. Oh, Mike.
Well, you can't read that? Well, you didn't go to English class? That was his strength in there, too. See, his has got the beat up one. That means I gotta do everything twice now. That sucks. Alright, so we have to figure out the balance on all this stuff. Okay, I go find some more parts. We'll be back. Okay, we're back. We had to go find some rods and some other parts that we're missing. There's light. So this is the 45 connecting rod. This is a Sportster connecting rod. It's a little bit bigger everywhere, except up here. So it's the same length as the Sportster. So you line up the same. The width is a little bit different that way and this way, and a lot different this way, where it makes them stronger. So that's why we're using Sportster rods. These flywheels are made to run the Sportster crank pin in them. That's why they have a big hole. Here's our Excel crank pin. And it goes in here, which we're going to need. Here, you get to hold that now. So this goes into here like this. And we have to see how thick this sticks up to figure out what nut we're going to use, because we have S&S thick nuts and we got S&S thin nut we just found. The difference in height is 20 thousandths. So see how low this is right here? See how nut's way thicker than it needs to be? Now this is going to pull in a little bit, but it's not going to pull in 50 thousandths. You worried about that falling over? That's the heavy side. Okay, so this is why we have a thin nut here. See, these are made for applications that require thin nuts. So that's a thin nut. The difference in height. It's not a lot, but it's enough. You still might have to cut it down even from there. So see how this has a flat shoulder here, and this has the countersink under it, or cutaway. So that goes against the flywheel. So that goes right there like that. So see how much sticks above? So if this hits on the side of your crankcase, which it might, we'll have to trim this nut off. Which will accept the balance, but we won't know that until we put the crank in. But for now, you can see how it's going to get cut down. I mean, it can get cut down another 20. So we're going to use this set here. And we're not going to use these ones. That's why we have multiple pieces around here. This says stick on it. I'm still missing all the thin ones somewhere. Somewhere is a bag of 10 thin ones. That ain't it. Okay, so we got that figured out. Okay, so we hand picked out this set of rods here. They're not worn too much, so they haven't been hammered on. There's no marks in here of anything hitting. No impact marks. There's no evidence of being overheated or hit with a big hammer on top like that one had. They haven't been hitting the beam. So they look really nice. The races haven't been shifted basically hardly at all. They got this one's moved just a tick, it looks like, but we're going to put new parts in there anyway, and they'll go in there good and tight. If not, I'll make sure we'll put oversized ones in there. So anyway, they look really nice. They fit together. Everything looks good. So we're going to use this set. Okay, now the last thing to determine is what we want to do on cages. The original cages are steel. Steel ones don't really wear out. I have seen them wear out, but it's pretty rare. Okay, aftermarket is aluminum. So aluminum ones are lighter, which means less shaking, less vibration, but they do wear. So it's a trade-off.
Steel.
So everything's better about aluminum except for the wearing part. Now on Big Twin there's more rollers per cage, but I think on Sportster they're the same. Yeah, they're the same all the way around. No extra roller. I also think the rollers are the same between the two cages as I recall. Yep. Yep, same. Okay. So you want the heavier ones in there, not the light ones?
Yes.
Okay. So you get these. Now these you do have to make sure that they're not worn heavily, if at all. So you want to look in the bottom down in the cage in here, make sure they're not a big round circle run with a big cup hole in it. So see how there's no real wear in there at all. See how that one has a little bit of a mark in there, but it's not worn very deep. You can see a mark in it. So it does have some wear, but nothing super heavy. See, there's no wear. You can't see it anywhere going deep. So this one has more wear than these. but they're good. Okay, that's it for now. Rest break. Okay, I got everything laid out here. I got, we found a set of rods we're going to use. I got the balancing stuff set up here. I got this all leveled out now. I dug up the crank pin, bearings, the thicker nuts, all that stuff. We're going to go with the steel cages. Got the key that goes in a crank pin. I had to go find some wrist pins because I didn't have any set up here. So I thought I was going to use Ironhead Sportster wrist pins, but they are almost as long as this, which is basically the width of the piston. So they weren't going to work. They're like an 1/8 inch shorter than this one. This is stock Evo piston. But it turns out that the Evo 80 inch piston pin from Wiseco is the correct one. So that allows me to use that. These are the round wire locks we're going to use, probably. If not, it'll be the bigger one, but I think it's set up for the small one. These are 49 thou thick. The newer one is 59 thou thick. So I measured the hole down there. Looks like about 50 thou wide. So I'm going to try that clip, and if it doesn't work, I'll use the bigger one. But I'll weigh it with these. A little different weight there, don't matter. So that gives me all the parts to weigh up. So I'm not going to do it tonight. I got stuff I got to get done tonight. So we could go ahead and fill out all this paperwork up in here, get all our numbers figured out, and then figure out what kind of a bob weight to put on the flywheels to balance them. So a bob weight is something like this. Goes on here. Boom. This will be a custom weight one, so I'll have to see what it is. This one's set up for my single, so but I got a bolt in it so I can add washers to it or whatever I need for more weight. So that's how you balance them statically. So that's what we're going to do, but we have to figure out how heavy this needs to be. These are, this is my twin cam one. This is my Evo universal one. These are preset for Evo Chevrolet panhead. That's my normal one. So, lots of them laying in there to choose from. And we'll just make what we need. So anyway, I'll do this probably Sunday. I'll play around with this a little bit. So anyway, we got it all ready to balance it. It's getting late, and it's early for me. It's 9 o'clock, but I gotta get to bed before noon, which will be midnight. Seminar to go to tomorrow. Let's get some education. Go learn about car crap. All right, so that's it for tonight. So this set here, we got all set up, and then the other sets over there, we'll have to figure out his separately because it's all different weights. So we have to keep these separated, so make sure we get the right one. Yep, this is Bill's motor. So even though it's just the same basic build, it's completely different parts, so we have to keep the parts separated. So, all right, that's it for tonight.